Now, just like we can specify default arguments for our formal parameters, we can also specify default arguments for our type parameters. In this example, I have this template function with an integer as a default argument for the type parameter t. Now, this is not particularly useful for template functions, but we'll see examples with template classes later on. For this particular example, we can have a pointer in the main function, and since we return a pointer from that instantiate template function, we can return the address of that pointer on the heap in that way, and we typically leave the angle brackets empty, that is to make use of the default type arguments. Should you have template functions with multiple type parameters, then all type parameters after the first type parameter with a default argument must also have default arguments. This is similar to providing default arguments for your formal parameters. Again, the main difference here is that we are providing a type as a default argument. Here's the example in Visual Studio. I do the template, type name, the type parameter is t, and the default argument I set to int for t. The function name is instantiate, and it's going to return a pointer to t. So by default, if we don't specify a type, it's going to return a pointer to an integer. Then in this line, I create a local pointer, which I call local pointer, which is also a pointer to t, and I allocate a new dynamic variable on the heap, new t. In other words, the object on the heap is also going to be of type and of size t, and for this demonstration I simply initialize that and I give it some value 55 just for demonstration purposes, and then I'm going to return the local pointer. Again, that is just an address. Then in main I create a pointer to a type of integer which I initialize to null pointer. Then in the next statement I go and call that function instantiate, so the compiler is going to define a function for us based on this template, and of course it's going to return this object that's on the heap now, an instance of that object on the heap, and assign that address to pointer, and I simply print that out here. Just remove that extra semicolon, the reference pointer to print that out, and then of course later on we want to deallocate whatever that pointer is pointing at. If I build and run this should print out 55. The problem comes in if you change this here to something like a float, then you'll get an error. A value of type pointer to an int cannot be assigned to pointer to float. But that is fine because that is simply the default argument or the default type. So we can use float here or double. Change that around so you can use double as well. If I build and run, that will simply print out 55 again. If we change this here to double, then we don't even need this right here. We can build and run and this will work fine. We can also have default arguments for struct or class type parameters. In this example, I have a template struct with default argument for its type parameter. In this case, that default argument is an integer. So I have type name t, the assignment operator or the equal symbol, followed by int. And then we have some struct entity. Now for the construction for this example, you'll be doing entity, empty angle brackets, and then entity1, the instance name. And note once more that for templates with multiple type parameters, all type parameters after the first type parameter with a default argument must also have default arguments. I'll show an example of where we'll use default arguments for a struct or a class type parameter later on in the video. Before we move on to the next example in Visual Studio, I want to introduce non-type, also referred to as value parameters. Now a template non-type or value parameter is an integral or enumeration parameter instead of a type parameter. In this example we have a template function, so we mark that with the template keyword. Within the angle brackets we have type name t, so that is a regular type parameter. Then we do comma and int size. Now that is familiar, right? That is similar to a pass by value parameter. And then you have the function definition. You can also have a struct or a class template with non-type parameters. As you can see in this example, we have a template struct with an integer non-type parameter. Right, we mark the struct entity as a template using the template keyword, and then between parentheses we have a regular type parameter. We have type name t, and then comma, and then int size, so that is a non-type parameter. And for the construction, you'll do entity, the angle brackets, pass in some type argument float for the type parameter t, and for the second argument within the angle brackets we can pass in 5 for the non-type parameter size, which is of type int. And of course you follow that by the identifier or the name for the entity that you are constructing, in this case entity1, and if that has some constructor you'll follow that by the parentheses and you'll pass in the arguments. Before we move on, I have an exercise for you. In the previous section, we created this instantiate function. It is marked as a template, so it's a template function. And then we have this default argument for the type parameter. Now what I'd like you to do for an exercise is I'd like you to add a non-type parameter. Okay, in this list, I'd like you to add a non-type parameter because it would be nice in main if we could specify, let's say, using a value such as 55. Okay, we can pass in some integral value maybe to initialize this object on the heap. Currently we can't do that, we'll get an error. Now of course you can do that through a formal parameter, so creating a formal parameter for the function, but try and do this using a non-type parameter instead. I'll add that non-type parameter in this list right here. Call that x or something. And then we can do new t. The object that we allocate on the heap, which is going to be of type t, we can initialize that. In this example using x, which is an integer. And then we can pass in some value in here, so I'll do 55 again. And if we build and run, that works fine. In this next example, I have a template struct called arrayEntity, and I have a type parameter. Okay, we do type name t, and then comma, and then we have a non-type parameter int size. And then what I'm going to do is void toString, so this is a member function. And down here I have an marray, which is an array of type t, and it has size based on what we pass in. And I'm just going to do the list style initialization for that, so that we don't get garbage in the elements that we do not initialize. Now the toString function is going to loop through those elements and print them out. We set int I to 0, and then as long as I is less than the size, we do shout marray I, and then we do I++, we increment I. In this way we loop through that array. Okay, now scrolling down to main, this is how I'm going to instantiate that array. So I do arrayEntity, and we want to do an array of what? Well, an array of integers, and I want to pass in 5, so it's going to have 5 elements. The name of this is going to be arrayEntity1 for this example, so I can do arrayEntity1.marray0, pass in the subscript 0 to assign 44 to the first element in that array, and then I can do that object name, so arrayEntity1.toString, which again will go and loop through all of those elements and print them out. Okay, build and run that, and you see we get 44 and 4 zeros. This is just a simple example to show you that you can use non-type parameters in your templates. Now one final thing before we move on is if I try and provide a default argument for the type parameter, in this case int, let's say I want this to be an array of integers by default, then if I hover over this, we'll get default argument not at end of parameter list. If I Ctrl B to build this, we'll get an error, missing default template parameter parameter2. Now of course what you can do is you can provide a default argument for that size non-type parameter, so in this case int size, and I set that to 4. Then I don't have to provide this information. So I take that away and build and run. And as you can see, that works fine. We have 4 elements and we've set the first element to 44 using this statement right here. You can undo if you want. I'll just leave it like this for the next example. And before we move on, I have one more exercise for you. Currently, we are doing this toString function in main so that we can print out all of the elements in the array. Now that's fine. But sometimes we want to iterate through those elements somewhere else, such as in the main function or some other function. And it would be nice if we could use the subscript operator to do that with the arrayEntity1. Then maybe we can do something like this. Okay, you can do a statement like this instead of a statement like that. The subscript operator is not overloaded for the array entity. And of course, if we cannot do this, then we also cannot loop through here in main. This is important because we are not always going to use structs. For the most part, for your containers, you will likely be using classes so that you can put your array or your list in some private section to protect that data, so that we can only manipulate that data by using member functions. And of course, if this was a class, then we can have as a public member function, we can overload the subscript operator, and through that we can then manipulate the array. So we can read from or write to the elements in that array through that subscript operator. For an exercise, convert the struct into a class and then make marray private. Then you want to overload the subscript operator to work with the class. Then instead of using the current toString function, I wanted to write a for loop in main to test the overloaded subscript operator. Alright, let's convert this array entity into a class. This array member is now private, so we can no longer do this statement right here. And this is what we'd still like to do. And I'm actually going to comment both of these lines out. And that is the overloaded subscript operator. Now let's see if we can do this right here. I'll test it one more time using the toString function. Build a run and that works fine. You might be confused why we can do this. Remember that this operator is basically going to return an L value because we specify an index, which this is going to take in. So this right here is basically going to fetch an object, some integer or whatever that type is. It's going to return that or fetch that, and then we are going to return that back. So we're going to return an L value because that thing exists in memory. So that is why we can assign to it. And here we simply fetch that again and we print it out. Build a run and that works fine. Alright, so I hope you found this subsection interesting, and again this is where operator overloading comes in handy, and I'm trying to give you the opportunity to practice that in these sections. As I mentioned, you can use integrals or enumerations for your non-type parameters for your templates. Now in this example I have an enumeration called eSize, and I'm going to use that for the size of the array. So you can see what I do in the private section right here is I use that to specify the size of the array instead of using an integer or a short. Now I would like to note that if you do a float here, a float or a double, you'll get an error. Floating point template parameter is non-standard. And the same with a double. I'll use an unscoped enumeration for this example. We have the overloaded subscript operator, and then in main I'm simply going to instantiate that, provide the type argument which is going to be int. In other words, the array is going to be an array of integers, and then for the size of the array I do eSize 2, and then I can also use that in the for loop right here, eSize 2. That will get converted to an integer, and in the enumeration, the enumerators right here, you can see I initialize the first enumerator, which is 1. I initialize to 1. We don't want that to be 0. Remember, with an enumeration, the enumerators start at 0 by default. And of course, we do not want to create an array of size 0. We want 1 or more elements. An array of 0 elements is pretty useless, right? I can build a run and that works fine. One final thing I'd like to note is I mentioned that you can have integrals or enumerations as non-type parameters, that is for your templates, but you can actually have references or pointers to classes or structs, or to functions or member functions, but you can have many issues with those. So in this example, I simply do a struct and entity template. In the toString function, I'll do entity.member. Entity comes from right here. I have a global static entity, which I'll just call entity. I use list initialization to set the member to 55. So this struct entity up here, that member will get initialized to 55. Then in main, I go and pass that in right here as an argument to the non-type parameter for the template. The instance here is called entity template, just for a quick demo. So I do entity template.toString, and I can build a run. That works fine. But if I go and change something, or if you try and do something like this, or if I construct the entity right here in main and I pass it in and Ctrl B to build, you'll get an error because it has non-static storage duration, and that cannot be used as a non-type argument. Undo a few times. You can also do a pointer, change that to a pointer. The non-type parameter for this template is going to be a pointer to an entity, and then I can do, what does a pointer take? It takes an address, so we get the address of that entity, and because that is now a pointer, we have to change this right here from the dot operator to the arrow operator. Ctrl F5 to build and run, and that works fine. I'm just demonstrating this to you because I've seen very few examples on this. It is unlikely that you'll see it used in this way. For the most part, you'll be using integrals, That is for your non-type parameters. If you start using pointers or references to classes and structs or to functions, then you can start to run into all sorts of problems. So try and avoid that. Try and stick to integrals such as chars, ints, shorts for your non-type parameters. Always remember that char is also an integral type. For example, for this example, I specify a non-type parameter for the template, a char, which is an integral type as I mentioned, and I just call that myChar, and I'm simply going to print out that myChar, and in main I pass in h, and then I do toString, build and run that, and that should print out h just fine, and that's what we get. So you probably won't see non-type parameters all that often in production code, but I wanted to show it to you here so that you know about this functionality. Alright, I'll see you in the next video.